Good day, everyone. I want us to quickly solve this problem. Now, a body is, let's move this here like this. Now, a body uniformly accelerates from rest at 8 meters per second squared. In how much time will the body travel a distance of 2.5 kilometers? A body uniformly accelerates from rest at 8 meters per second squared. In how much time will the body travel a distance of 2.5 kilometers? Now, what I will always say is that please try as much as possible to commit the equations of motion to your brain. It is very important. If you don't know that, I don't know what you want to do. If you complain that you don't know how to solve problems on equation of motion, it's because you don't actually know the equations of motion offhand. Because when you know them, you discover that other things will be very simple. Now let's quickly write the equations of motions this side. So we are going to say V equals to U plus AT. That's kind of the first equation of motion we're going to write. So we also have S equals to UT plus half V squared is equals to U squared plus 2AS, and we also have this S equals to U plus V over 2 times tan. So now we have written these equations of motion. Now the next thing is that before you start solving your problem, try to bring out your parameters. Well, it's part of the steps to solve the problem. Now you have to read the question carefully and bring out all the parameters from the question. It is very important. So now I'm going to start bringing out the parameters. Remember, the question says a body uniformly accelerates from rest. Now, whenever a body starts from rest, whenever a body starts from accelerates from rest, then something is going to be zero. Something is going to be zero. This rest, something is going to be zero, and that is the initial velocity. This means u equals to 0. When the body accelerates from rest, u equals to 0. So you come down and you say u equals to 0. Why is u equals to 0? Because the initial velocity, because the body is starting from rest, so the body was not moving initially. So the initial velocity is actually equals to 0. So what is the next thing? Continue reading. At 8 meters per second square. At 8 meters per second square. Now, what is measured in meter per second square is actually acceleration that is measured in meter per second square. So I'm going to write that my acceleration is actually equals to 8 meter per second what squared. Do you understand that? Now, remember, I said when a body starts from rest, you have to watch out for that. It's very important. That is part of the skills you should possess. So whenever you are trying to solve question, know everything about it. The question says from rest. Some students don't even know that when they say from rest, they're going to say u equals to 0. So they are going to complain that the parameters are not complete, and then so please note, whenever a body uniformly accelerates from rest, then the initial velocity, which is u, is going to be equals to 0. Please take note of that. Then the at 8 meters per second square, meaning that our acceleration is 8 meters per second squared. Then we continue reading the question. In how much time? Imagine somebody asking you in how much time, meaning that you are being asked for time. So meaning that in how much time will the body, in how much time? The question is actually for time. So meaning that the question didn't give you time, but it's asking you for time. So meaning that time is going to be part of your parameter. So you're going to say t is equals to unknown parameter. So you're going to put a question mark, meaning that you don't know, because the question says in how much time, so the time is going to be part of your parameter. That is exactly what you're looking for. Please take note of that. Know how to get your parameter out of the question. It is very important. So next thing, in how much time will the body travel a distance of 2.5 kilometer? Now, this 2.5 kilometer is represent distance, because the question say, will the body travel a distance of what? 2.5 kilometer. Now, what do we normally use to represent our distance is s. We know that already. So distance is equal to 2.5 kilometer. Well, this kilometer here that you are seeing here is actually not the SI unit of distance. It is not the SI unit of distance. So you have to know the SI unit of distance, which is what? The SI unit of distance is meters. The SI unit of distance is actually what? Is meters. You understand? This is the SI unit of distance. So meaning that when they did not give you distance, you have to do yourself the favor of changing the unit. Now, let me tell you something. The time must be given in seconds. That is the SI unit. The distance must be given in meters. But if they are not given in SI units, then they are going to change. For example, let me quickly show you this. The time, the SI unit of time is actually seconds. The SI unit of distance, this is seconds. So let me change it seconds. The SI unit of distance is actually what? Is actually meters. You understand? And the SI unit of mass. You understand? Mass. SI unit is kg. It has to be kg. Do you understand? So please, when they are not given in their SI unit, please change them. Change them. Change them. Change them. I'm repeating it. Change them. Otherwise, your answer is going to be wrong. Now, looking at this 2.5 kilometer, it means you are going to change this kilometer to what? To meter. Nobody's going to tell you change now, change now. No, they're not going to tell you something that you yourself have. You have to know it, that you must change when they are not given in SI units. If the time is given to us in minutes or hours, we have to change it. Please take note of that. It's very important. That's why you complain that you do not get the answer. So that is that for that. Now, having known that, then the next thing is that this is going to give us what? What is the distance going to give us? So how do we change from kilometers to meters? Well, it's simply by multiplying your kilometer, your distance by 1,000. So you remove the kilometer, so you multiply by 1,000, and it is automatically going to become meters. Multiply by 1,000, please. So meaning that I'm going to say 2.5 times 1,000, and it automatically become meter like that. So I would say my S is now equals to, my S is equals to what? Now, that's going to be 1 like this, 2, 3. You understand? That's going to be 2, 5, 0, 0, 0, 0. So that's going to be 2, 5, 0, 0. That's 2,500 what? Meters. Now, what I simply did was trying to multiply, So if you say 2.5 times 1,000, you're going to get 2,500. Now, the next thing is that we are done with our parameters. We have brought up all the parameters from the question. Then the next thing you're going to do is that you're going to check the equation of motion to use. This is another thing. Check the equation of motion to use. Check the equation that has all your parameters. You understand? Check what? The equation that has all your what? All your parameters, and substitute. Now, if you look at the first equation does not have distance, and I have distance in my parameters. So the first equation here does not have this distance. So I'm not going to use, means I am not going to use it because it does not have distance, right? Good. What about the second equation? We have x equals to ut, s is there, right? U is also there, well. What about time? The time is also there. because I'm being asked to look for time, so it's part of it. What about acceleration? Well, acceleration was also given. So meaning that this equation x equals to ut plus rvt squared is actually the right equation to use to solve this problem. That is how you check the equations you are going to use. So I'm going to write the equation right away. I'm going to say s equals to ut plus half a t squared. So once I write that, then the next thing is I'm going to substitute. So anywhere I have s, I'll put 2005 because s is 2500. So I'm going to write 2500. 2500 is equals to, but don't forget the initial velocity is actually 0. So I'm going to say 0 times t. And the t I don't know, so I'm still going to rename my t there. So 0 times t plus is actually t. Then plus half times acceleration is 8. Well, I'm going to put it there. Then times t squared times t what? T squared. Don't forget the squared on top of the t. Please don't forget that. It is very important. Then the next thing is that you are going to have the 2500 written again. Then it's going to be equals to, then this actually becomes 0. 0 times 6 becomes 0. So and also at this side, I'm going to say 2 year 1, 2 year what? 2 year 4. 2 year 4. So it's going to be 4 times t squared. That's going to be 4t squared. 4t squared. So now, how do I solve this? It means that I have to look for t and not 4t squared. So the first thing is I'm going to eliminate this. The right way to do this is to kind of eliminate this 4 by dividing both sides by 4. So if you divide both sides by 4, what are you going to get? So I'm going to say my t squared. So I will say my t squared is equals to 2500. Now what I want to do is that for clarity, because some people might not know, might be asking the question, how do you get that? Well, it's actually like this. So I will say 2500 divided by 4 is equals to 4t squared divided by 4. So this 4 is actually going to cancel this 4, and then I'm going to have, well, it's going to remain t squared here. So I'm going to say t squared is equals to, how many 4 am I going to see in 2500? Well, 4 in 25 is actually what? Is actually 4 times 8, 4 times 6, 24. So it's going to give me 6. Remain 1. So if I put the 1 here, it's going to be 10. 4 in 10 is actually what? 2. So it remains what? 4 times 2 is 8. So it remains 2. I'm going to put the 2 here. So 4 in 20 is going to give me 5. Now remember, we are looking for, we are looking for what? We are looking for, I'm going to complete the rest here. We are looking for t, not t squared. So how do we cancel the squared? Well, it's by bringing in square root. We know the square root is going to cancel the square. So I'm going to say take the square root of both sides. So which I'm going to say the square root of t squared, I would like to show it, is equals to the square root of 6 to 5. So meaning that I'm going to say this square now, we cancel this square root. So it's going to remain t. So t is going to be equals to, what is the square root of 25? What does it mean? It means what is that number that will multiply itself 2 times to give you 625? Well, the number is 25 actually. So the square root of 25 times 25, meaning that the square of 25 is 625, but the square root of 625 is 25. So that is that. So I'm going to say the answer is 25. Well, then you decide. The time is measured in what? It's measured in seconds. So I'm going to put seconds like this. So this is the answer to this problem. Thank you.